After we've talked about the special stabilization the benzene molecule experiences, it's now time to look at some reactions that you can do with this special molecule. And something that you would expect from our previous lecture series is that you can use this pi electron density in the way that we discussed, so that we can add an electrophile and then a nucleophile in this two-stepped reaction mechanism to form to basically do an electrophilic addition reaction. But this is actually not observed, because if you would do that, you, as we have discussed, would consume the double bond, and with that you would receive a non-aromatic product. And this is not a good thing, because you lose a lot of energy and you need to put in a lot of energy to actually perform this reaction in the first place. So this is something that does not happen. What instead happens is, if you add an electrophile to these aromatic components, in general, in the most easiest case, benzene, you see that you receive so-called substitution reactions, where one of the protons is eliminated, and instead you have this new electrophile attached to your benzene core, and so you exactly see the substitution reaction. And in this way, the aromatic core of the benzene molecule is preserved, compared to when we would perform the addition reaction, where the benzene, this aromatic core, would be destroyed. And here on the right hand side you see the energy scheme for the reaction. We have here our benzene molecule. It interacts with an electrophile here, and in the first place our electrophile approaches our benzene molecule from either side. It wants to interact with the pi electron density above and below the ring plane. It approaches our ring, and then it forms this intermediate non-aromatic carbocation, where like slowly one of the pi bonds is basically broken. To add this electrophile, we are building up a carbocation, and this positive charge is then delocalized in this benzene core. And in the second step then, the carbon-hydrogen bond would loosen up, and in the end a proton would get eliminated, and in the end our electrophile would have substituted our hydrogen atom that we've previously attached to our core.